Here's something I wanted to give you a little bit of practice on. Dealing with quadrilaterals, something that we haven't done a whole lot of in terms of this specific type of problem, and so I just wanted to look at it with you and talk through a few of these. This says choose the most specific name. So our potential names are like parallelogram, rectangle, rhombus, how about square? Then we've got a kite, a trapezoid, and an isosceles trapezoid. These are all of the quadrilaterals we have talked about, or all of the specific ones. Of course, there's just general quadrilaterals that don't fit into any of these categories too. But in terms of choose the most specific name, and it really isn't, it's more classification than name, but I just wanted to make sure you understood what that meant. A rectangle is more specific than a parallelogram. Rectangles are parallelograms, but there are extra things that are true about rectangles that aren't true for every parallelogram. So that's a little bit more specific than just saying parallelogram. Or if I had a choice between do I use trapezoid or isosceles trapezoid, if it is an isosceles trapezoid, that's what I would call it, because that's more specific than just generic trapezoid. Or square is more specific than rhombus. A square is a rhombus, but it's a rhombus about which other certain things are true. In other words, a rhombus that also happens to be a rectangle is a square. So you want to use the most specific that you can. All right, so looking at number 1 here, the only thing that is shown to me by these markings is that I have 4 congruent sides. Okay, 4 congruent sides is pretty much the definition of a rhombus. So I'm going to call this a rhombus. I want to think about if I could get more specific than that. And the only thing more specific than just saying rhombus would be if it were also a square, but I don't know that. In order to think that this is a square, I would have to also see 4 right angles. Excuse me, and I don't see 4 right angles, so I can't say that. Let me point out, or I could see congruent diagonals. That would also tell me that I have a square, because congruent diagonals make it a rectangle. And if something's a rhombus and also a rectangle, then it's a square. Let me point out one thing I didn't say up here. This is assuming all of these are parallelograms. Okay, so we are assuming we have parallelograms to begin with. Actually, that's not true. On this one we are. Really, we don't even need to assume it. The 4 congruent sides says all that we need to know. All right, let's look at this one. This is not a parallelogram. This is why I went, oh wait, that's not true, because this one is not a parallelogram because it only tells me one pair of sides is parallel. That's what those arrows mean. So if that's the case, if I only know that one pair of sides is parallel, then it's definitely a trapezoid. Now, is it an isosceles trapezoid? Not necessarily. I would have to know that these 2 sides that aren't parallel were congruent, and I don't know that. So I'm just going to say trapezoid. All right, let's look at number 3 here. I have 4 right angles, so it's a rectangle. Just because it has 4 right angles automatically, it's a rectangle. I also have opposite sides are congruent. Opposite sides are congruent is something that's true for every parallelogram, so that doesn't really tell me anything additional because we already know that rectangles are parallelograms. So this is a rectangle. All right. Number 4, in contrast, tells me both things. It tells me I have 4 right angles, and I also have 4 congruent sides. So the 4 right angles make it a rectangle. The 4 congruent sides make it a rhombus. And anytime we have a figure that is both a rectangle and a rhombus, that's a square. All right, let's look down here. These are 2 more that aren't necessarily parallelograms, so that's why I took it back after I said that we were assuming that. We're not assuming these are parallelograms. Here I have 2 congruent sides that are not across from each other. They're not opposite. They're next to each other. We call that consecutive. So I have 2 consecutive sides here that are also congruent. That's the definition of a kite. So this is a kite. And last but not least, I have 1 pair of parallel sides. That makes this a trapezoid. And this time, the 2 sides that aren't parallel are indeed congruent. That's why this one is an isosceles trapezoid. Okay, hope that helped.